Today's video is going to be all about this. This add-on board for the DIYBMS controller provides current monitoring capability, just like the existing current monitoring device I originally designed way back in June 2021. Since then, the Texas Instruments chip used in that device has proven to be elusive. So let me introduce an alternative. This is a tiny add-on circuit board for the controller. It provides nearly all the same features as the existing device, but is soldered directly to the controller, so no need for RS485 cables or programming a separate tiny chip. As you can see here, the board only requires a few passive components, which I'm soldering using hot air. You have to love the way the parts jump around whilst the solder takes hold. This board uses a similar sensor chip as used in the original current monitor, but the SPI variant, the INA229. Amazingly, it's a chip you can actually buy, even directly from Texas Instruments. The pins on the chip are tiny, so careful soldering is needed. Hot air is generally easier for this, and a magnifying glass to check afterwards. Rather than forcing you to buy yet another version of the controller, I've designed this add-on to be compatible with all versions of controllers which use the ESP32. For once, I've actually made some detailed documentation, so all these instructions and diagrams are on GitHub, and the links are in the description of this video. Notice that the soldering locations may vary depending on the controller board you have, and you might need to add wires to connect to the correct pins. Sometimes the version number on the PCB isn't enough to determine which board you have, so read the instructions carefully. I'm going to install this on an old controller board, which is version 4.2. This is probably the most difficult one. All of these instructions are on the GitHub repository. This board is described as version 4.2 with J14 missing, and has the additional unused TX2 port on the front. On all the controller PCBs, the add-on board is soldered onto the reverse of the PCB. It's connected to the 4 pins used for the screen connector, along with 4 pins which vary depending on which board you have. I'm going to heat up the existing connector and slide the new PCB into the molten solder. If I were using a newer board, I could now simply use a pin header, push into the remaining holes and soldered on. But as this is an old controller board, I'm going to have to solder 4 additional wires, along with removing the unused opto-isolator from the top of the PCB. I'll also solder on some wires which run to the shunt and for the voltage sense. These can then be routed through a hole onto the top of the PCB. It's probably worth using some hot glue to hold the wires to the back of the board for extra strain relief. Now, I do need to mention a significant difference between the external current monitoring device and this add-on board, and that's isolation. The external current monitor is electrically isolated from the controller when you connect using RS485 cables, so there are no problems if the controller and current monitor are running from different power supplies. If you're going to use the add-on board, you also need to ensure that the negative of the battery is connected to the controller. You will also need to power the controller directly from the battery. Avoid any mains powered USB adapters. The controller must be provided with a regulated 5-volt supply, so you are likely to need some sort of step-down DC to DC converter from the battery voltage to 5 volts. Don't forget about the fuses. So to repeat, you need to avoid ground loop issues, avoid mains powered USB adapters for powering the controller if you're using this add-on board. Once you have soldered the add-on board to the controller, you will need to update the controller's firmware to the latest version. You can watch the previous video for instructions on how to do that. One thing to note, if you install this board, the SD memory card won't work properly if you go back to an older version of the firmware. You would have to completely remove the board to return to normality. In the DIYBMS current monitor page, select the internal current monitor from the options, and then it operates and performs exactly the same as the external board. You obviously don't get the extra relay normally found on the external current monitor, so these values are redundant. You connect up the shunt just as you would with the external device into the positive power supply cable from the battery to the loads and the charger. The 2 sensor wires connect to the shunt sense screw terminals. The ground or negative of the battery is connected to the DIYBMS ground. Don't forget to use that regulated power supply. Finally, a voltage sense wire is connected to the positive of the battery. I would recommend putting an inline fuse into that wire near to the battery end. So there you have it, a fully integrated current monitoring, state of charge and amp hour counting device inside the DIYBMS controller. I've made a few of these add-on boards for Patreons, so I'll be in touch if you would like one soon. Now, this isn't all. If you have yet to build your own DIYBMS controller, I've also integrated the current monitor directly onto the PCB. This is version 4.6. At the time of producing this video, I've not received my boards to test from JLCPCB. So once I've tested them, I'll publish the new controller version into the master branch on GitHub. I've a discount code for JLCPCB in the description if you are planning to make an order soon. Thanks for watching, and consider subscribing for more content like this.